This week we are learning chapter 7.3, Sum and Difference Identity. This session is much easier compared to chapter 7.2. All you need to do is to pick a formula and plug in. That's all you need to do. Here are the formula for this session, Sum and Difference Identity. We see three sets here. The first set has sign. So for sign function, I know they are alpha and beta, but you can think A, B, doesn't matter. It's just a variable. Represent two angles. Okay, so sine A plus B, the formula is sine A times cosine B plus cosine A times sine B. A quicker way you can read this kind of as a joke. You can say sine A plus B is sine cosine. Okay, so sine, if it's a plus, and then the formula still stays as plus. Sometimes they are different. I'll show you another example. So for minus, right, sine A minus B is sine minus cosine. For cosine A plus B, if it's A plus B, cosine A plus B is equal to minus sine. And cosine A minus B is plus sine. The last sets are tangent. So it's tangent A plus B. The numerator stays as a plus, however, the denominator is minus. For tangent A minus B, the numerator stays as minus and the denominator becomes a plus. Luckily, we do not need to memorize the formula here. However, you do need to plug in carefully, okay? Example 1, they want us to use a sum or difference identity, which is a formula you guys see on the previous page. I'm going to get it here again. So here is the formula, okay? And also post this formula on Canvas for you guys to use. To find what? Cosine. For cosine, to find cosine 375. For cosine, here's the only one we have here, right? Either plus or minus, either A plus B or A minus B. Let's see which one are we going to use. Again, so 375, we need to find the exact value. What are the ways to find exact value? Unicircle, right? Unicircle is the only way we can find the exact value. Let's go ahead to find the unicircle. Okay? Again, I'm going to pull out my unicircle here. Okay, here's my unicircle. So let's look. Do we have an angle 375 here? I see the largest one is 330. I don't see 375. So now you're going to tell me if we can find a number that add together or subtract, that will give us 375. Okay, what about the first set? The first number I think of that add or subtract together that give me 375 is, what about, can I use 330 and 45? You can use any number, any other values you find, okay? That will give you 375. It doesn't have to be 330 and 45. As long as you find those numbers on the unit circle, that's all you need. Now let's see what can we do. It's A plus B, right? Two numbers. Can we use the formula? I see addition, so definitely they're going to give us a, here is the formula we're going to use. Okay, cosine that plus B, A plus B is a minus sine. So which means cosine 330 times cosine 45 minus sine 330 times sine 45. Okay, how to find those values on the unit circle? Just a quick review here. So when you see cosine of a number on the unit circle, that is the x coordinate. If you see sine on the unit circle, that will be the y coordinate. I know some of you guys can find this number really quick. So 330, which is right here, cosine, that will give me radical 3 over 2. Times the cosine 45, which is right here, okay, x value, which is radical 2 over 2. Minus sine 330, which is negative 1/2, times sine 45, the y value of 45 degree, radical 2 over 2. Now we can simplify it. Radical 3 times radical 2 together is radical 6 over 4 minus negative radical 2 over 4. Okay, minus minus is a plus, right? So plus radical 2 over 4. They have the same denominator. You guys can combine that together. So the best way to write your answer, please write it as radical 6 plus radical 2 and then over 4. That will be your final answer. Here is another way to solve this question. So we have a cosine 375. That number is greater than 360, so we can do cosine 375 minus 360. That gives me cosine 15 degree. So cosine 15 degree basically is the same as cosine 375. Now we need to find cosine 15. We don't see a cosine 15, but I see cosine 15 can write as 45 degree minus 30 degree. Okay, so that also has a here the formula we can use cosine A minus B to solve this equation. So cosine 45 times cosine 30 plus sine 45 times sine 30. Okay, you simplified it. The cosine 45 is at 45 degree, the x coordinate. And the cosine 30 is 30 degree, the x coordinate. Sine 45, radical 2 over 2, sine 30, which is 1/2. Look, you're getting the same answer. So it doesn't matter which way you are doing, you can find any other number as well, as long as it is add or subtract together from the unit circle that gets 375 degree. Your final answer is radical 3 plus radical 2 over 4. Here we find the value of sine x plus y if x is less than pi over 2 and y is less than pi over 2. And we are given sine x is equal to 3 over 5. Sine y is equal to 12 over 37. Okay, we're going to start with the formula sine equal to x plus y. Because it's a sine x plus y, so we are looking at the first formula here that I'm highlighting right now. According to the formula, it is sine A times cosine B, so it will be sine x times cosine y plus cosine x times sine y. Okay, let's see, what do we know? We already know that sine x is 3 over 5, so we can plug that in. We do not know what is cosine y, but we know what is sine y, which is right here. 12 over 37. Now we need to know the other two variables we do not know before. So to find cosine y, we have a sine y, which is 12 over 37. To do that, we can draw a right triangle here and make the lower angle as y. Because sine y is 12 over 37, so we have opposite and hypotenuse. 12, and 37. Okay, so we need to find cosine y, which is adjacent over hypotenuse. We can find adjacent side by using the Pythagorean theorem in this right triangle. 12 squared plus x squared equal to 37 squared. I know the number is a little big, but you can definitely go ahead to figure out. So x squared equal to 37 squared minus 12 squared. X equal to square root of 37 squared minus 12 squared, which is equal to 35. Okay, that gives us the cosine y, which is adjacent over hypotenuse, which is 35 over 37. 35 over 37. Okay, we can use the same method to find cosine x. That given sine x is 3 over 5. We draw a right triangle. Now we're going to make the lower right angle as x. Sine x, which is 3 over 5, so we have an opposite over hypotenuse, which is 3 and 5 here. We need to find cosine x, which is adjacent over hypotenuse. To find the adjacent, we can use the Pythagorean theorem again. 3 squared plus x squared equal to 5 squared. This is a special triangle. We easily can know that x is equal to square root of 5 squared minus 3 squared. X is equal to 4. Okay, so which means we have an adjacent over hypotenuse. So here is a 4 over 5. Now we can continue to figure out the solution by simply simplifying. Okay, so 5 and 35, you can use your calculator. You don't have to do it by hand. Okay, 5 and 35 is cancel out. You can have a 7. 337 cannot do anything, and the other side not really. Can't simplify it much. You can definitely use your calculator, so much faster. 21 over 37 plus 4 times 12, 48 over 5 times 37, which is 185. Definitely use your calculator, okay? This is little bit big. We're not practicing how to add the fraction together. Okay, if you put that into a calculator, make sure with your TI-83, you want to put a parentheses, right? So you are getting the right answer. And if you are getting a decimal from your calculator, make sure press math, enter. That's how you convert to a fraction. So your final answer should be 153 over 185. Number 3. The question wants us to use sum or difference identity, which is the one we've been using throughout the course. Right here, I take it out again. To find the exact value of 285. Whenever you see they want us to find the exact value, what do you think of? We need to use the unit circle. Okay, so I take both things out, so that will help us to solve this question. Okay, another important information in this question is use the tangent. Okay, so now we can only look at these two formulas. Just like example 1, you can find any numbers on the unit circle. Either add or subtract together. That will give you 285. Okay, so let's see what are the two numbers to add or subtract together from the unit circle. Okay, we are looking at degree, so all these values here add or subtract together, that will give me 285. Some people might say, what about 240 and 45? Both these numbers 240 and 45, they are on unit circle. and they do add up equal to 285. Good job, that is one of the answer. Or you can do tangent of, also find another number, 330 minus 45. Let me double check, 330 minus 45. Yeah, that will also work, right? Okay, as long as both of these answers are on the unit circle and they add or subtract together, that will give you 285. That's perfect. Okay, so you don't have to do both. Here, I'm going to do the first one. Tangent A plus B, 240 plus 45. That gives us the first formula to use here. Plug in, equal to tangent of 240 plus tangent of 45 divided by 1 times the tangent of 240 times the tangent of 45. Okay, make sure you remember on the unit circle, what is a tangent? So you know that cosine is x, sine is y, tangent is y over x. Okay, so 240, then you will have negative radical 3 over 2 divided by 1 half plus tangent 45, radical 2 over 2 over radical 2 over 2 divided by 1 minus negative radical 3 over 2 over negative 1 half times radical 2 over 2 divided by radical 2 over 2. Okay, so look, we're going to start with the first part here. Here is the first fraction I see. Okay, make sure do it slow, okay? The first one I see what? Keep, change, and flip, right? That's the only way you can simplify in here. So radical, negative radical 3 over 2, keep, change, and flip, times 2 over 1. And here I see the second one, second big fraction. We do also slowly. Oh, by the way, what are these? We don't have to write it out because it's radical 2 over 2 divided by the same number again, which becomes just 1. If sometimes it's so obvious, you don't have to. 1 minus, what is it? Negative radical 3 over 2 times negative 2 over 1. And the last one here, the same number divided by itself, that gives me 1. So times 1. Okay, let's keep simplifying. This question is going to get a little long because I'm showing every single steps. Okay, let's simplify in here. The first fraction, okay, can I cancel out 2 and 2? Negative times negative becomes a positive. So you will have radical 3 plus 1 divided by 1 minus negative times negative disappear, 2 disappear. So becomes negative and the negative that becomes a positive. So here stays as negative radical 3. Okay, can this be our final answer? Oh, no. What's the reason here? Because I see 1 minus radical 3. You cannot have a radical in the denominator. So we need to do a little bit more simplifying. Okay, if you just has a radical 3 by itself in the denominator, you know the way to get rid of the radical will be multiplying radical 3 on the top and the bottom, right? But here is a little different. We see 1 minus radical 3. So the way to get rid of the radical 3 is to do the conjugate. 1 plus radical 3 on the top and the bottom. All we need to do is distributing, then we should be able to simplify this equation. Okay, the top, there's no trick here, unfortunately. You have to just do one by one, okay? So radical 3 plus 3 plus 1 plus radical 3. What about the bottom? The reason we are multiplying 1 minus radical 3 times 1 plus radical 3, Does that remind you guys the difference of square? A square minus b square, which is a plus b times a minus b. We have a plus b and a minus b. 1 minus radical 3 times 1 plus radical 3. So all we need to do here is to do 1 square minus radical 3 square. Difference of the square. Okay, now I think we are getting rid of the radicals in the denominator. What is in the numerator now? I have a radical 3, I have a radical 3, so together I have 2 radical 3. 3 and 1 together, I have 4. 1 squares 1 minus radical 3 squares 3. Okay, so 2 radical 3 plus 4 divided by negative 2. Your final answer, make sure when you're dividing, you have to divide every numerator by negative 2. Because you only have one term in the denominator, that's what you have to do. So 2 times radical 3 divided by 2 is negative radical 3. 4 divided by negative 2 is negative 2. Our final answer here is negative radical 3 minus 2. Okay, here at the beginning of the question, I also mentioned that you can definitely try the second way, right? Tangent 330 minus 45. You will get the same exact answer at the end if you try the other number. So it doesn't matter what number you eventually pick from the unit circle. You don't have to pick the one I have here. As long as you follow the formula, at the end, you should get the same answer. Here is the last type question in this lesson. We need to verify that cosecant 3 pi over 2 plus a is equal to negative secant of a. Okay, so when you're doing verifying, so the same strategy before, right? You want to start with the more complicated side. So I can clearly see that the left-hand side is more complicated. The right is longer, so we're going to start with the left-hand side. Okay, we have the formulas here. I'm going to take out all the formulas we have here. We have the purple paper. We need those, right, when you're doing verify identity. And we also have for today's new formula in this session, which is the difference, sum and the difference identities or formulas right here. Okay, so let's get it started. Cosecant a 3 pi over 2 plus a. Cosecant, do we have a formula that we can change cosecant? Cosecant, I know that is 1 over sine, so we can definitely start with that. So nothing changed, right? So become 1 over sine 3 pi over 2 plus a. And then we do not change the right hand side, so stays as negative secant a. Okay, does that make sense, right? You do not want to change it. Doesn't matter what is inside the parentheses. Cosecant is 1 over sine of the same number inside the parentheses. Now I see sine, two numbers adding together. Do we have a formula for that? Sine A plus B is sine cosine, which is sine 3 pi over 2 cosine A plus cosine 3 pi over 2 sine A. That equal to the right hand side. We didn't do anything, so keep it there. Okay, let's continue. When you see a trigonometry number with an angle, right, we can actually figure out what that is, right? So when you need to figure those numbers out, you know you need your unit circle. So here is my unit circle. Let's see. Sine of 3 pi over 2. Where is 3 pi over 2? 3 pi over 2 is right here. Sine of that, which is a y value at 3 pi over 2, which is negative 1. Cosine A, that's another number in the unit circle, stays there. Cosine 3 pi over 2, what is it? x value of 3 pi over 2, which is 0. So 0 times sine A, that disappeared, right? Equal to the right-hand side. We didn't make any change. It stays the same. So becomes 1 over negative cosine A equal to negative secant A. Oh my God, seems really close. What is 1 over cosine A? Do we have a formula for that? 1 over cosine is just equal to secant, so that is just negative secant A. That give me the same as the right hand side. Great, I complete my mission here. Left hand side is equal to right hand side, so it is an identity. For this type of question, your conclusion will always be an identity, okay? So if you didn't figure out the left hand side is equal to right hand side, you may make some mistake here or there. You can always go back to check and figure out.